After taking this walk, the person is now 10 km east and 5 km north of the point of origin. The resultant displacement is represented by the arrow labeled dr. So using the ruler and the protractor, you can measure on this diagram that the person is 11.2 km from the origin at an angle theta equals 27 degrees north of the east. In other words, resultant displacement vector has magnitude of 11.2 km and makes an angle 27 degrees with the positive x-axis. The magnitude length of the dr can also be obtained using the theorem of Pythagoras in this case, since d1, d2, and the dr form right triangle with the dr as hypotenuse. So here, based on this formula, Pythagorean theorem, that absolute magnitude of this displacement is square root of 10 km squared plus 5 km squared. So this is same as square root of 100 plus 25, which is square root of 125 kilometer squared. So that unit can come out of the square root. So that is same as 11.2 kilometer. You can also use Pythagorean theorem, of course, only when the vectors are perpendicular to each other. So resultant displacement, the vector dr, is the sum of the vectors d1 and the d2. As you can see in this figure, this is a vector equation. Important feature of adding the two vectors that are not along the same line is that the magnitude of a resultant vector is not equal to the sum of the magnitudes of the two separate vectors, but it's smaller than their sum. So basically dr supposedly smaller than d1 plus d2, where the equal signs, the equals sign applies only if the two vectors point in the same direction. So this figure illustrates the general rules for graphically adding two vectors together. No matter what angles they make to get their sum, the rules are as follows. First of all, on a diagram, draw one of the vectors, call it d1, and make it to the scale. The next, draw the second vector d2 to the scale. The placing its tail at the tip of the first vector and being sure its direction is correct. An arrow drawn from the tail of the first vector to the tip of the second vector represent the sum or resultant of the two vectors. Well, the length of the resultant vector represents its magnitude. Note that the vectors can be translated parallel to themselves, maintaining the same length and angle. To accomplish these manipulations, the length of resultant can be measured with the ruler and compared to the scale. Angles can be measured with the protractor. This method is known as the tail to tip method of adding vectors. The resultant the resultant is not affected by the order in which the vectors are added. For example, a displacement of 5 km north to which is added a displacement of 10 km east yields a resultant of 11.2 km and angle 27 degree. The same as when they are added in reverse order. That is now using the V naught, the V bar to represent any type of the vector. So B1 plus B2 same as B2 bar plus B1 bar. So this is called commutative property, which is known as some different way of the vector addition. So even if you draw this D2 first and then draw the D1 later, that it results in the same outcome of vector addition. So the R should be same as this method. The amplitude and the direction of this resultant displacement should be the same as the D1 plus D2. The tail to tip method of the adding vectors can be extended to 3 or more vectors. The resultant is drawn from the tail of the first vector to the tip of the last one added. So the first tail of the first vector to the tip of the last one. And an example is shown in this figure. The 3 vectors could just represent displacements, northeast, south, west, or perhaps 3 forces. Check for yourself that you get the same resultant no matter in which order you add the 3 vectors. That is V1 bar plus B2 bar plus V3 bar, the same as V1 plus bracket V2 bar plus B3. This is called associative property. So it doesn't matter whether the first 2 vectors are added to each other and then third vectors added to that, or the second and third vectors are added together and then first vector just added to them. They are pretty much the same. So basically these first 2 vectors could be combined first and then third vectors added, or second, third vector they combine graphically, and then first vector is added to these 2 vector summation. So even if the vectors are not right angles, they can be added graphically by using the tail to tip method. Second way to add 2 vectors is the parallelogram method. It is fully equivalent to the tail to tip method. In this method, the 2 vectors are drawn starting from the common origin, and the parallelogram is constructed using these 2 vectors adjacent sides as shown in this picture. So now you see that the first vector pointing the east, and the second vector is pointing northeast. So the first method is tail to tip method. So the tail of the first vector going all the way to the tip of the second vector. So you put these 2 vectors together and then just draw the straight line from tail of the first vector to the tip of the second vector. Parallelogram method is just to put the two origins of the two vectors together at the same spot, as you can see here, and then to create the parallelogram, as you can see, and then create the straight line from origin of the two vectors all the way to the other end of this parallelogram. So this parallelogram, the straight line across the parallelogram is indicating that the addition of the two vectors. So you got to be careful. In parallelogram, the straight line shouldn't be drawn from the tip of the one vector to the tip of the other vectors. That's completely wrong, incorrect way of adding the two vectors. So resultant is a diagonal drawn from the common origin. So that the tail to tip method is shown here, and it's clear that both methods yield the same result. As you can see, this one and this straight line, these two vectors added, or they are pretty much the same. Now we can define the subtraction of the one vector from another. The difference between the two vectors, v2 bar minus v1, is defined as like this: v2 minus v1 equals v2 bar plus bracket minus v1 bar. So this is the same as the difference between two vectors equal to the sum of the first plus the negative of the second. So our rules for the addition of the vectors can be applied as shown in this figure, using the tail to tip method. So here v2 indicating the northeast, and now you subtract the v1 representing the vector in east direction. So this is just same as v2 plus the negative the v1 bar. So the b negative vector of the v1 is the same as the opposite direction of the b1 vector. So now you just add these two vectors together using the tip to tail method, so that you put the two vector tip to tail, and then just create a straight line from the tail of the second vector to the tip of the negative first vector. So the vector v can be also multiplied by the scalar c. The result is a vector cv bar that has the same direction, but the magnitude is c var, c times v. So if c is negative, the resultant vector points in the opposite direction. So if c is 1.5, then now you multiply 1.5 to the vector v. So v2 is 50% longer than the v. So that is, this one is 50% longer, but their direction is the same. If the vector v3 is multiplied by minus 2 to the v, then the size of this vector is twice bigger than the v. It's like 200% longer, but because of this negative sign, that direction is opposite to the this original vector.